Hi, today we'll be doing some more exploratory data analysis. This means we'll be cleaning some input data by adding column names, formatting dates, dropping rows, adding columns, dropping columns, and grouping and sizing our data. And all of this using R and Python. We'll be using same dataset for both R and Python, and I'll also be doing a side-by-side comparison of the code used in each language. Let's begin. I'll first show you what the data to be cleaned looks like, and then I'll take you stepwise how the data is cleaned and then used for analysis. This is our input file. It is a TSV file and it has 6 columns. As you can see, there are no column names in this file. So the first thing after we import this file that we'll be doing is adding column names to this data. The next thing that we will be doing is converting this number field into proper date field, and this one as well, and then splitting this field, which is a combination of city comma state, into 2 columns, which will be called as city and state. And then we'll be doing analysis on our final data set. Let's begin from R. This is a statement that we use to import files. I have already run the statement, and we see that there are 61393 observations and of 6 variables. If we open this file, we see there are no column names, and just how our spreadsheet was, that is, the data is in a similar fashion. Our next step would be to rename these columns from V1, V2, V3 to proper names. So this will be date occurred, date reported, location, short description, duration, and long description. The code for that is names UFO will have C and then all the names of the columns. And then when we do head UFO, we can see all the names. So let's run these steps. And now when you see, all the columns have proper column names. Next, let's see what data we have in the date field. We see that date is usually of 8 characters. So what we can do is, in case there are any junk values or troubled rows, we can eliminate those rows. So these are the steps that we will be running to eliminate the bad rows. The first step is to find out which are the troubled rows. These are a list of rows that we can see. There are a lot of rows. So let's count how many are there. So we'll be using the length function, which will give us how many rows are there. So there are 254 rows. So let's get all the rows using this set of lines. The if-else function will give you a true-false information. So let's run this in step. I'm just hitting Control Enter, and we see that you will get a logical output of true and false. Let's see what is the length of the rows that are not good. So this exclamation mark means not good. So let's run this, and it's again 254, which is what is matching from here. And then let's see how many are really good rows. So it's 61393. Next, what we will be doing is we will be multiplying these good rows with the UFO data, and only the rows that are true will be moved into UFO. Next, if we run the head statement again, head UFO, you will see these are the rows and columns. The number of rows have reduced, but the number of columns are still going to be the same. Now let's see the corresponding code in Python. Here again, the read CSV function will import the file. SCP equal to \t means that it's a tab delimited file, and that is how our program will be segregating the columns. In this statement itself, I have added code to name the columns as well. So I have named the columns as date occurred, date reported, location, short description, duration, and long description. And only the first 6 columns have been taken, just in case if there were 10 additional columns, and if I only want selected few columns, this is how we will be doing it. When I run UFO head, I can see a sample data of the first 5 rows. UFO info will give me some more information about the columns and the number of entries. So we have number of entries as again 61393, and this is a description of the column. It has taken the first column and the second column as integer and the rest of the 4 columns as object. Next, let's print a number of rows that don't have date in them. So we have 254 rows that have date equal to 0. Then that was for date occurred. Let's see in date reported. If we run that, we'll get 0 records that are of length equal to 0. So this is a statement of how to delete the rows that don't have date information. After dropping all the records that don't have date information in them, we are left with 61139 entries. We initially had 61393, so it has approximately dropped 200 records. Next, what we will be doing is we will be formatting our date columns. Let's do that first in Python. This is a statement to underscore date time will convert our date time, our integer column into the format of Y, M, and D. Capital Y means it is a 4-digit year. If you change it to small y, it will take only 2 digits of the year. We converted it into as type string to quickly format our date into Y, M, and D. Errors equal to coerce means we will have to, if there are any bad dates, it will remove those records. Say for example, we only have the year part in the date and the remaining field and the remaining parts are 0000, then it will eliminate those rows. Let's run this statement and see. The info statement tells us that it hasn't deleted any of the entries and there are 61139 records in date reported and 61136 records in date occurred. So there is a mismatch. Next, let's see how the code works in R. So far what we have done in R is we have eliminated all the rows that do not have good date values and then updated our UFO dataset. Next, what we will be doing is we will be changing the format of our date fields. So we'll be changing the format of date occurred to YMD and date reported to YMD. When we execute this line, this is how it changes our data. So date occurred is the format is updated to the date format, but date reported is still in the old format. Now, when we run the date reported field as well, this is what it looks like. Next, what we will be doing is we will be splitting our location column and we'll be splitting this into city and state. So let's begin. Let's see a sample data and see how the comma can be used to separate our data. S1 has no comma and S2 has comma here. So if we use str split statement, it will split our S1 by comma and S2 also by comma. So let's see how this works. Because there was no comma, so it did not split our data for S1. And because S2 has comma, so it has split data into 2. First has comma and second has here. And we also see that here also has a space in it. We also have to remove that space. I created a getLocation function which will do exactly the same thing. It will try to split the data and then also eliminate the space. Let's run that statement. Now let's see what's in the location. It's Iowa City, IA. And when we use a split function on that column, it splits our location into city and state. But we also see that the state has an extra space. So let's try and use the getLocation function and see how that works. We see that there is no extra space before the state. So our function is a good function. Now let's do the same thing in Python. Here again, we'll be splitting our location into city and state. For that, we'll be using the str.split, and the comma here tells us that we have a comma delimiter, and s plus means if there is any excess space. N equal to 1 means it will split column wise. Once our data is split, the location column is no longer relevant, so it will become redundant. So we will drop this column, and since our data already is now split into city and state, we have to merge this df1 data frame into the UFO data frame, and note that it will be appended towards the end of the data frame, not in the middle. So we'll be dropping the location, and we will be joining the two data frames, that is UFO and df1, and we will also be renaming our columns. The str split function has named our column as 0 and 1. So we will have to rename a column into a more legible way, which is city and state. And then because our city and state are towards the end of the data frame, I have just rearranged my data frame into by just naming the columns in a series. So let's execute this entire set and see what we get. So this is what we get. A city and states are now split. Next, what we will be doing is we will be comparing the state with the actual 50 states of the United States. And the data that are not within, and the states that are not within these 50 states will be eliminated. The reason we are doing this is there can be bad data. So we will be using the as is in feature of the data frame to drop the records. We see that it has dropped a lot of our records. We initially had 61139 entries, and now we have 51669 entries. Let's now see what our data looks like. Our data still looks the same. It still has 7 columns with city and state split. The date columns are now in the date format. But one thing that we notice is that the numbers are not continuous. So this is 77 and this is 79. And there are a lot of rows because we have eliminated about 1000 rows. The numbers of our rows are now mixed up. So we will be resetting the index. This will reset all the numbers here on the left, and it will only give you continuous numbers. Let's see what we can do with R. We have done so far in R is we have split our location column into city and state, and then with the do call we have our bind the city and the state data into our UFO data frame. Next, what we'll be doing is we'll be matching the 50 states with the states already in the UFO dataset, and those that are not in the 50 state set will be, those records from UFO dataset will be eliminated. So we have created a small data frame with all the 50 states. And let's see what's in the UFO dataset state column. Now we will be matching the US states column with US.states data frame. After matching the columns, what we will be doing is we will be removing those data sets those records that do not have the 50 states, and then adding them to the updating the UFO data set with the valid data only. Now we see that UFO.us is a new data set that we have created. It is a subset of UFO, and it now has less rows than the original data frame. And this is because some of the records in the UFO data frame did not have the correct information. Next, what we'll be doing is we'll be using the date occurred field and the uh, count field to find out the number of sightings people have seen each year. So we'll just move the date occurred into the UFO.US data frame, and we'll pick up the year and month part from that new data frame, UFO.US, and then we'll be using the counts function to find out how many sightings were seen in a specific year. So you can see for each state and for every month of the year, the number of sightings that were seen is being recorded here. Let's see what we can do in Python. Now let's count the number of sightings since 1990, and this we will be doing year-wise. In this, first we will have to do is we will have to select only those records in UFO that are greater than 1990 January 1st. Once we have those records, we will group by the records according to year, and for that we'll be using dt.toPeriod function. And to count the number of records in each year, we'll be using the size function. The name of the size column will be sightings count. And once we have this function ready, once we have the results ready, we will be displaying the results using the year-wise function. This is the result that we get. In these past 20 years, these are number of records. So the number of sightings has increased with the year. Next, what we will be doing is we will count the number of sightings in each state. For that, we will be grouping our data state-wise using the group by function again, and then use a size function to count the number of sightings in that state. And then I wanted to sort the data by the number of records in each state. So I'll be using the sort function, I'll be sorting the data in descending order. My size function result will be under the column name sightings.count. So the maximum sightings have been found in California and Washington state, and the least has been in DC and North Dakota. I hope you have enjoyed today's video. Please leave your comments in the comment section. Thank you.